Section 6.4 is on factoring trinomials using the AC method. So if we have a polynomial that looks like 2x squared plus 7x plus 6, we notice that we can't use our method from before because we notice that the coefficient of x squared is no longer 1. And so we notice if we tried looking at things like factors of 1 and 6, so 1 times 6 equals 6, 1 plus 6 equals 7, the trouble is we have that 2 out in front, and so we could try doing things like 2x plus 1 times x plus 6, or x plus 1 times 2x plus 6, but we notice neither of those are going to work. The 2x plus 1 times x plus 6 would give us 2x squared plus 13x plus 6. The x plus 1 times 2x plus 6 would give us 2x squared plus 8x. Where is it? 6x, yep, plus 8x plus 6. Neither of which is correct. So they were both wrong. So we could guess and check. We could try saying, okay, what if we tried saying 2x plus 1? Nope, we don't do 2x plus 1. We could try 2x plus 2x plus let's try it. 2x plus 3 times x plus 2, and we notice that would give us 2x squared plus 3x plus 4x plus 6, which is the 2x squared plus 7x plus 6 that we wanted. But we notice guessing and checking is not at all reliable. So what can we do instead? We notice that the AC method tells us that we can first, so let's write it this way. Step 1 is to arrange the polynomial in the form ax squared plus bx plus c. So if it's not in that format, we're not going to use the AC method. Step 2, we can multiply the coefficients a and c. So we multiply a times c. We now look for factors m and n, so that should sound familiar. Such that m times n equals a times c, and m plus n equals b. So this is a very similar process to what we saw for factoring polynomials of the form x squared plus bx plus c. The difference now is that we can then rewrite the polynomial as ax squared plus mx plus nx plus c, and then factor by grouping. And what's nice is that if we can find m and n that have those properties, m times n equals a times c, m plus n equals b, we'll always be able to factor by grouping. So if we look at that 2x squared, if we look at that same 2x squared plus 7x plus 6 again, we know what the answer should be, but we're going to see how can we get that answer using the AC method. We start with 2 times 6 is 12. We notice 12 factors as 1 times 12, 2 times 6, 3 times 4, and we notice that 3 plus 4 is 7. And so we can rewrite the polynomial as 2x squared plus 3x plus 4x plus 6, Then we can factor by grouping. We get x times the quantity 2x plus 3, plus 2 times the quantity 2x plus 3, and so we get x plus 2, the quantity x plus 2 times the quantity 2x plus 3, which is the same factorization we had gotten before by guessing. And we'll notice that this AC method is much more reliable. You'll also notice that the order of the factors doesn't matter. So x plus 2 times 2x plus 3 is the same thing as the quantity 2x plus 3 times the quantity x plus 2. We don't have to worry what order things are in. So we'll do a few more examples of these. We notice that if we tried something more familiar, if we looked at y squared minus 6y minus 40, we notice that our old method of factoring trinomials, we notice that that is literally the AC method. We just notice that in this case we notice a equals 1, c is negative 40, and so AC is negative 40, and so we like factors of negative 40 that add up to negative 6. So we have to go down the list. We have negative 1 and 40, negative 2 and 20, negative 4 and 10. That would give us positive 6, so we just have to swap the signs. So make it 4 and negative 10. 4 plus negative 10 is negative 6. And so we can say y squared plus 4y minus 10y minus 40 is going to give us y times the quantity y plus 4 minus 10 times the quantity y plus 4, and so we get the quantity y minus 10 times the quantity y plus 4. Let's make sure that's written correctly. Y plus 10. The quantity y plus 10 times the quantity y plus 4. Notice y minus 10. Always be careful not to randomly change signs. And you notice we can always verify by multiplying. We notice if we multiply it back out, we would get y squared plus 4y minus 10y minus 40 equals y squared minus 6y minus 40. We'll try another one. Let's try 16h squared plus 24h plus 9. We notice now we have to multiply 16 times 9. Gives us 90 plus 54 is 144. And we notice that we can go down the whole list, but we notice 12 times 12 is 144. 12 plus 12 is 24. And so we could write this as 16h squared plus 12h plus 12h plus 9. That's then going to be 4h times the quantity 4h plus 3 times the quantity 4h plus 3. And so we notice we're going to get the quantity 4h plus 3 times the quantity 4h plus 3. So it turns out that was a perfect square trinomial. And so if we happen to notice that's a perfect square trinomial, we could have saved ourselves some time. Sometimes we'll also notice that we can do some factorization using greatest common factor. That'll make our lives easier. So if we saw something like negative 6p cubed minus 21p squared minus 9p, before we try doing anything with factoring by the AC method, we first notice that there's a common factor of negative 3p. If we factor out that negative 3p, we're left with 2p squared plus 7p plus 3. And now we notice that we can take 2 times 3 is 6, 1 times 6 equals 7, 1 plus 6 equals, 1 times 6 equals 6, 1 times 6 equals 6, 1 plus 6 equals 7, And so we know that thing in parentheses we can write as negative 3p times 2p squared plus p plus 6p plus 3. And so we can write that as negative 3p times, we can write that as p times the quantity 2p plus 1 plus 3 times the quantity 2p plus 1. And so we get negative 3p times the quantity p plus 3 times the quantity 2p plus 1. You notice, like we mentioned in section 6.2, sometimes we'll get a polynomial that's prime. If we try looking at 4z squared minus z plus 2, we notice if we take 4 times 2, that equals 8. We can look through the factorizations of 8. We get 1, 8, 2, 4, negative 1, negative 8, negative 2, negative 4. None of those sums add up to negative 1. So 1 plus 8 is 9. 2 plus 4 is 6. Negative 1 plus negative 8 is negative 9. Negative 2 plus negative 4 is negative 6. And so we know that this polynomial is prime. There is no factorization for that polynomial. We can also have more than one variable. We notice that if we looked at 4x squared plus 5xy minus 6y squared, we typically don't worry about the variables, but you notice we could. We notice that we can technically say a times c equals negative 24 x squared y squared, and so we can look for factors of negative 24 x squared y squared that add up to 5xy. So we can look at that as negative 1x positive 24y, negative 1xy, 24xy, negative 2xy, positive 12xy, negative 3xy, positive 8xy, and we notice that's a positive 5. We notice that negative 3xy plus 8xy gives us 5xy, and so we can write that as 4x squared minus 3xy plus 5xy minus 6y squared, and now we can factor by grouping. We get x times 4x minus 3y plus y times 5x. You notice, what did we do wrong? You notice I wrote negative 3xy plus 5xy, it was supposed to be negative 3xy plus 8xy. So always be careful of transcription errors. That is going to not be good. Transcription errors are always bad. So we're in negative 3xy plus 8xy, and so now we can factor out a common factor of 2y, which leaves behind 4x minus 3y. And so we get the quantity x plus 2y times the quantity 4x minus 3y.